Are we okay with adding two functions? Or does this seem a bit mysterious? Linda, are you with us? Are we still together, or are you bored? Do you know the sum rule? Huh? So we know that to add two functions, right? If we do a simple little table, if I say x, actually I need one more column. If I have an x, I have an f of x, I have a g of x, and then I have f plus g. I should write of x, but you know what I mean. So, for -2, -1, 0, 1, 2, any number, then f is some number. Here, let's say it's 4, and g is 3. So f plus g is 7. At x minus 1, f is, 1, g is 2, so 1 plus 2 is 3. When x is 0, f of x is -2, and g of x is 1. -2 plus 1 is -1. And so on. So f plus g is just adding the values of the two functions for every point x.
Maybe you're going there. I want to ask, what is the derivative?
Yeah, this is not about the derivative. This is just what does it mean to add two functions, right? So that we're clear what is this thing talking about. This thing is just saying I have one function, I have another function, I just add the values of the two functions for each point x. That's all, okay? So that's what f plus g is. So when I have that, and I add the two functions, and you'll see this becomes very useful very quickly. Actually, let me motivate. Why do we want this? If I give you a function, x cubed minus 2x squared plus 4x minus 6, and I ask you, what is the derivative of this function? If you don't know the sum rule and the difference rule, the only way you have to do this is to go back to that formula, the limit, and which is painful. You can do it, but it's painful. Yeah, it will work, but you would rather not do that. So the easier way to do it, now, you know the constant rule and you know the power rule. And you say, well, this looks like a power, and this looks like a power. Actually, the x squared looks like a power, the x looks like a power, and the 6 looks like a constant. I know what to do with this, and this, and this, and this, but what do I do when they're added and subtracted together? This is now my question. How do I deal with the combination of them? Right? Can I just do this? But these are different terms. What do I do? Okay? And this sum and difference rule, so I could say, okay, this f of x is like saying, okay, x cubed is like a g of x, 2x squared is a h of x, 4x is gh, let's call it, I'm running out of letters, j of x, and 6 is L of x. I have 4 functions, and here I have subtracted, here I have added, here I have subtracted. Right? G of x is x cubed, h of x is 2x squared, j of x is 4x, L of x is 6. And I know what to do with each of these. I know the derivative of x cubed. I learned how to do that. That derivative is easy. Right? What's the derivative of x cubed? 3 power 2. What is the derivative of 2x squared?
4 minus 4.
So it's 2 times x squared. We haven't actually gone through this, but you can see, yeah, it'll be 2x times 2, which is 4x. So this will be 4x. These are the derivatives now. This is g prime, h prime, J prime is, what's the derivative of 4x? So what's the derivative of x?
X is
1,
1.
right? So 4 times 1 is 4. And the derivative of 6 is L prime is 0, what we just saw. So I know each of these derivatives. Is there a way to combine them to give me the derivative of f? This is what we want to know. Okay? And the answer is very simple. It's the simplest answer possible. What do we think is the answer? Wait. It's simply f prime plus g prime. If I have the derivative of the sum of two functions is the sum of the derivatives. Yeah? So here I can separate. I can say, let me write it more like this. I can say d by dx of f plus d by dx of g. So I d by, just like, think of it like the when you're multiplying, when you have 2 times x plus y, what do? You say 2x plus 2y, right? Now, d by dx is not a number, it's an operator, but kind of in the same way, the operator applies to this and the operator applies to that. And that's all. Now, if this was a minus sign, if this was a difference, not f plus g, but f minus g, what do you think happens here? If instead of the plus, if we have a minus, what happens to this side? It's also minus. Right? So as a shorthand, we will sometimes write, you know this plus minus, you know it from the quadratic equation, right? Minus b plus minus the square root of, remember? So plus minus is if it's plus or minus, and then we write this. And the way it works is the one that is on top goes with the one that is on top. And the one that is below goes with the one that is below. Right? And that's important because if I give you x plus y equal x plus minus y equals x minus plus negative y. This is just to make clear, the plus goes with the minus now. They're the top symbols, right? Minus times minus is plus. Plus times minus is minus. Okay? So plus minus, plus minus. So we have the sum and the difference rule together. Now, one rule we didn't... so now we're ready with this information. We can answer the question, what is f prime? Right? We said f of x is x cubed minus 2x squared plus 4x minus 6. What is f prime of x?
It's
3x squared Bas, aha, yes. Minus 0, which we don't need to write. And this is our answer. Yep. Oh, there's one rule that I didn't write here that I should write. Is the constant multiple, which is the combination, well, not exactly, of the power and, I shouldn't have put it there. Let me put it down here. Constant multiple. Constant, which we used, but I hadn't defined it. So if I have a function and a constant, so I have a c, a constant, and f. So given an f of x and a c element of the reals. Yes? I just want to, because we used it already, so I just want to write it for the record, but we already used it. We already know it. So this is c times f. If I take the derivative of a number times a function, not a function times a function, just a number, constant times a function, the constant multiplies the derivative. The derivative of, right, if I have a function 2x and a constant 3, and I say, what is the derivative of 3 times 2x? That's the same as 3 times the derivative of 2x. Which is what we did. We had 2x squared, and we did 2 times the derivative of x squared. This is 2 is a constant, the c. X squared is the function part, depends on x. So the 2 can sit by itself, doesn't go anywhere, doesn't become 0, right? It only becomes 0 if the constant is by itself. But if the constant is multiplying a function, 2 times something of x, then the 2 sits by itself, 2 times d by dx of x squared, which is 2 times the derivative of x squared is 2x, and so I get 4x. Yeah? Yeah, so we did it already. I just wanted to write it for completeness. Okay, so you want another example? What's your example? F of x
is equal to x power 5
x to the 5
plus 2x power 3
plus 2x cubed
plus x squared minus x squared.
minus x squared. That's it? Okay. So let's try this together. We want f prime of x. Yeah? So now we've learned that when we have, this is a sum and difference of 3 terms. We have an x5, 2x to the 3, and x squared. And they're separated by a plus or a minus. So these are sums and differences. So we can, how do we take the derivative of all of them together? Is we take the derivative of each one, and then we do the plus and minus. Plus or minus. So what is the derivative of this, x5? 5x to the 4, and then I have a plus. 3 times 2 is 6, x squared. See how good you've gotten already? You know how to take the derivative of a polynomial. Now we can give you any polynomial, and you would be able to do it. It's cool, huh? Constant multiple. They make sense. These ones are, you have to be a little more careful. They're not, when you calculate, I mean, they get a little bit more involved, but they're not complicated. They just need a little more care to use them properly. Okay, so we know these. Now, here's a fun question. can I take this is a function also, yes? We said the derivative is a function. Can I take the derivative of this function?
Of this function.
This one. So can I take the derivative of f prime? And we write f double prime. F prime of f prime, of f, yeah. F prime prime,
Yeah.
yeah? F double prime. So what is the derivative of this now?
It's 20
Hmm?
for u.
Mm-hmm.
It's 12 plus 12
Mm-hmm.
x.
Mm-hmm.
Uh, minus 1.
Minus? Close?
1. Minus 2.
So 2 is a constant multiplying x. The derivative of x is 1. 2 times 1. 2. Yeah? Do you think we can go another level?
Yes.
Is it still recording?
Yeah.
Yeah. Once the recording is online, you can also look up the recording online. You can still record, I don't mind. Just saying it'll also be there. Probably with better sound too. So we could keep going. You can keep because every derivative is a function. You can take the derivative of a function. So you can go f triple prime, f, and so on. Eventually, if you do this, what do you think will happen?
You can.
If you keep taking derivatives, will you keep getting different functions, or will it at some point you start getting the same thing over and over?
Yes.
What? 0. If you keep doing this, you will eventually reach f whatever, however many steps down. That derivative will just be 0. You're caught on, yeah, right? Every time you take a derivative, you reduce the power by 1. From 5 to 4, from 4 to 3, to 2, to 1, to 0. And then when it's 0, it's a constant. One more step, the derivative of the constant is 0. And each of these has already, right? Even in the next step, you see what was x squared became 2x, became 2. In the next step, this will go away. It will be 0. And the same will happen with this, and the same will happen with this. Now, this is true for positive exponents. If you had a negative exponent, then it will keep getting more and more negative. It will go forever. You'll have minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Keep going forward. But if you have positive powers, they will eventually reach, if you keep taking enough derivatives, it will eventually reach 0. So, how are we doing on time? It's 10 to 3. I don't know what you're doing here. 10 to 3. Yeah, let's cover product and quotient rules. Actually, because we only have 10 minutes, let me... okay, clearly it's not reasonable to expect that we're going to cover all of the calculus that's in the course outline in 3 weeks.
No.
Yeah. We should go at a pace. I would rather we cover some basics, but you know it well, than we rush and... yeah. Also, you're all studying for accounting, auditing purposes. You're not doing physics, you're not doing engineering, where you need all of the pieces you need, trigonometric functions and what. So I will go through and see what are really the key topics that you need, and the rest. So I was thinking this, but I'm going to change this. And we will take our time to really understand each of these steps, because it's much more useful and satisfying this way. Okay, product rule. So, as you might expect, the product rule asks, what happens if I want the derivative of an f of x? I'm going to drop of x. You know it's there, yeah? F times g. F times g. So if I have two functions and I'm multiplying the two functions, what is the derivative of that? Now, in some cases, it's easy enough to just do the multiplication, right? If you have x, f of x is x, and g of x is 3x squared, then you just say, well, x times 3x squared is 3x cubed, and then I take the derivative. But sometimes we have functions like, what about e to the x times sine of x? I'm just showing this as an example. I just said we're not going to do trigonometric functions, but just to show you why this is useful, why this is needed. Well, e to the x times sine of x, we don't have, what is the derivative of this thing? We don't know. We know the derivative of e to the x. This is e to the x. E to the x is a very special function. You should love e to the x. Because e to the x, when you take the derivative, you get the same function back. Now think about what that means. It means you can take the derivative twice, 3 times, 10 times, 1,000 times, you will still have the same function. It is the only function that has this property. Other than, actually the other function with this property is a very boring function, it's just f of x equals 0. What is the derivative of f of x equals 0? 0 is a constant, right? 0 is a real number. So what is the derivative of this? Is 0. Oh, it's the same thing. But that's a pretty boring function, right? You can't do very much with the 0. But this is the only, and it can be proven, this is the only function that is its own derivative. So we know e of x. Now sine of x, the derivative of sine of x is cosine of x. Okay? Now you might ask, oh, maybe the derivative of this product, e to the x times sine of x, is just this product, like we did with sums and differences, right? But the answer is no. It's not quite that simple.
So the derivatives of sine of x is cosine.
So this is the derivative of this. This is the derivative of this.
Actually, is e power x. So the derivative of e power x is e power x.
The derivative of e to the power x is e to the power x. Is its own derivative. Yeah. So, I'm only showing this to say as an example of a function where we don't know what this combination is, but we know what each of them separately is. I could do it with also x times e to the x. I know the derivative of x. I know the derivative of e to the x. I know the derivative of this. I know the derivative of this. I don't know the derivative of the combination. I don't know what is the derivative of this thing. I don't know. But I know each of them separately. So how can I combine the separate ones to find this? And the answer is, I need a bit more space, we don't need that anymore, is f prime times g plus f times g prime. So we can use it with this example. Or we can start with an even easier example, I guess. But yeah, let's do that one. So notice that now there's a sum. when you have a product of functions, the derivative of the product is now two terms. The derivative of one times the other function, plus the first function times the derivative of the second one. Okay? So for example, if we have x e to the x, and I ask what is the derivative of this, you can use this rule. You would say, here, f is x, g is e to the x. So f prime is the derivative of x, which is what? What is the derivative of x by itself, the f prime? So, sorry, let me not go too fast. F is this piece, g is this piece. So I'm multiplying f times g. So f of x is x, g of x is e to the x. Okay? And we're multiplying them together. And our question is, what is the derivative of this product of functions? They're both functions because they both have an x. So we say this is how you write the derivative. So we know f of x is x. What is the derivative, f prime? It's just 1. The derivative of x is 1. What is g? E power x. Plus, what is f? F is x. What is g prime? E power x, nothing changes. And so we have our answer. E to the x plus x e to the x. Shall we do another example? We'll do it with polynomials this time, not the exponential, but with polynomials. So we can verify the answer also. Okay. So give me a f, simple ones, not too complicated. We need two functions, f of x, g of x. So let's say f is what? H? We want a function of x. A function of x. So let's say x plus 3. Simple. Okay. And g can be x squared minus 1. Two simple functions. Okay? So we say, what is the derivative of x plus 3 times x squared minus 1? Now, this one, we could do it in two ways, right? We could expand this product, and then we would have a polynomial, and we know how to do a polynomial, and we can do that. So let's try that first, actually. So this is x times x squared. So it's the derivative of x times x squared is x cubed, right? X squared times 3, and they're both positive, is 3x squared. Minus 1 times x is minus x. And minus 1 times 3 is minus 3. Okay, so we have our polynomial. And we know how to take the derivative of a polynomial, don't we? So let's write it down. The derivative of x cubed, we know these are sums and differences, so we can do each one by itself, right? So what's the derivative of x cubed? 3x squared. What's the derivative of 3x squared? Plus 6x, very good. What's the derivative of this one? Minus 1. And the derivative of this? 0. So we have our answer. 3x squared plus 6x minus 1. Now, let's try it using our formula.
So we have answer. Yes.
So you could answer this way. This would be one way to do it. Yep. Now we want to verify, it's not a proof, but we want to verify that this works. Like, this should give the same answer. If this is correct, it should give the same answer. Okay? So we need f prime, which is the derivative of x plus 3. What is the derivative of x plus 3? Anyone? So the same thing, the derivative of x plus 3 is the derivative of x plus the derivative of 3. Right? Yeah? What is the derivative of x? 1. And the derivative of 3? 0. So the derivative of this, right, this is the f. So f prime, actually that's over here. That's right. F prime is 1. What is g prime? So what's the derivative of this?
2x.
2x. The minus 1 is a constant, so it goes. Okay. So we have our two derivatives, which were very easy to do. Yeah. So now we know f, we know g, we know f prime, we know g prime. We can now put them in here. So let's have f prime. Okay, so 1, f prime is 1 times g, x squared minus 1. So that's 1 times this is just this. So we have x squared minus 1 plus f, which is x plus 3, times g prime. G prime is 2x. Now we simplify. So we have x squared minus 1. This 2x times x is plus 2x squared. And 3 times 2x, 6x. And if we combine all this, we get x squared plus 2x squared go together. That's 3x squared plus 6x minus 1. Is this the same as this? Ta-da!
That's a wow.
So both of these ways work. And there's not, so one is not right or better than the other. It depends on the problem. You decide this looks like it will be easier to do it like this, or it will be easier to do it like this. That's up to you. I think Khan Academy somewhere has a section on how strategies for doing differentiations. Like you have all these rules, so which way do you go about it? Actually, it would be a fun exercise for us to think about. We have these rules. We haven't done the quotient rule yet. So we've done the product rule. The quotient rule, you want to finish it? It's 3:03. I actually have someone meeting me at 3, so I can't go longer today. We could do another session another day if you want.
Yeah.
So now I think you're ready to do more examples, more complicated ones. The other, just to tell you, these are the simpler rules. The other rules that I was going to introduce today, so this was the example, I'll take it out. The other rules I was going to introduce are called the chain rule, which is an important one. You need this one also. And actually, with the chain rule and the product rule, you can get the quotient rule. The other one is not a rule, exactly, but it's a procedure, I guess, called implicit differentiation, which can also be useful, although I don't know if it would be as useful for you. So we might skip implicit differentiation. But the chain rule we definitely need. We definitely need the chain rule and the quotient rule. So if you want to keep going and start learning about these ones, I think we'll start from here, probably next week. And then
You say,
I'm going to revise this.
you say that maybe we will from class.
Yeah, I'll tell you yeah. So for right now, you can find or keep going through the unit about the quotient rule and the chain rule. It's helpful, yeah. But I can see that it's